Right, in the last video we looked at a sign line for the first derivative. In this video we're going to look at a sign line for the second derivative. Okay, so what we're seeing in this graph is the function, a plot of the function f, and we're also seeing the graph of f prime. Okay. Could we sketch a graph of f double prime? And that would be possible to do because to find a graph of f double prime, you simply need to look at tangent lines to the first derivative. Okay? And we're noticing right here that there is a place where the graph, the tangent lines to the first derivative become 0. So there are two locations where the second derivative is equal to 0. Okay? We're seeing that the second derivative is a positive number here because the slope of the tangent line to f prime is a positive number, positive slope. Okay, and so we can draw the second derivative being positive. Every time you draw a tangent line to f prime, that tangent line is a positive number, so long as you're less than this number, at like around negative 0.5. But on this side of the place where the tangent line is 0 slope, our tangent lines go negative, right? So our second derivative is going to be a negative number. But we can see that we need to get up to this point where the second derivative became 0 again. And then after that point, tangent lines to f prime are positively sloped, and that is why the second derivative became positive. Okay, so what we're seeing here is a place right here and right here. We can see that the second derivative is equal to 0. Okay, for the function f of x being x to the fourth minus 2x squared plus 1, we know that the derivative is equal to 4x cubed minus 4x, and the second derivative became 12x squared minus 4. Okay, so what we can see here is that there are two places when the second derivative is equal to 0, and that happens when 12x squared is equal to 4, when x squared is equal to 1/3, when x is equal to plus or minus the square root of 1/3. Okay, so right here and right here is x is equal to negative square root of 1/3, and this point right here is x is equal to positive square root of 1/3. Okay, so if we're drawing a sign line for the second derivative, we put the places where the second derivative is equal to 0. Okay, and we put the other place where the second derivative is equal to 0. And we can see that we sketched the places where the second derivative was positive. It was positive to the left of negative square root of negative 1 over square root of 3. It was negative between the two places where the second derivative is 0, and then it became positive afterward. Okay, so what we have here is the fact that at x is equal to negative 1 over square root of 3, the second derivative changed sign. And because the second derivative changed sign, that is what we call an inflection point. So at x is equal to negative 1 over square root of 3, we have an inflection point because the second derivative changed sign. There is also an inflection point at positive 1 over square root of 3, and that is because the second derivative changed sign from negative to positive. So you also have an inflection point at positive and negative 1 over square root of 3. And you can see the inflection points from the sign line of the second derivative. And what we're seeing here is that the second derivative being positive means that the rate of change to the rate of change is that the rate of change is increasing. Okay, so the rate of change to the rate of change is positive. The rate of change to the rate of change is positive, but the rate of change to the rate of change is negative in some places. And back over here, the rate of change to the rate of change is again positive. So we have this changing second derivative happening. And when the second derivative stops changing, those are the critical numbers of f prime, and the inflection points are where the second derivative changes sign. So ends this video.